Okay. Um, Continuation with the revisions. Question 17 of worksheet 3. Sketch the piecewise functions. Sketch the piecewise functions. So, what is a piecewise function? Piecewise function is basically a function which has pieces of functions connected in one. So, multiple functions are being connected, embracing various conditions. That's the piecewise function. So, if you look at what is being given here, I have two functions connected to one. So it means that these functions are basically embracing these two conditions. This function can only be sketched with these values of x, and this function can only be sketched with these values of x. What do I do when sketching a piecewise function? Start by drawing your boundaries with respect to the what? The intervals. So we're simply saying that if this is my Cartesian plane, so the only boundary we have is x equals to 1. Because this is x less than 1, x greater than or equal to 1. So it means that at 1, that's why the demarcation will be drawn. So draw the vertical line passing through at x equal to 1. So this is x equal to 1. So it means that if this is the demarcation, one of these is going to be on the other side and one of the other is going to be on the other side. So if x less than 1, the less than 1 is on this part. It means on this side, that's where I'm supposed to experience x squared plus 4. And from here going to this, that's where I'm supposed to experience 2x minus 1. So what do I do to sketch this? So for x squared plus 4, you can be able to create a table of contents. X, 1. So since I'm looking at the left side less than 1, so I'm talking about from 1 going to my left side. So 1, 0, negative 1, negative 2, negative 3. So what are your values of y when x is less than 1? 1 can be 1, 2, 0, negative 2, negative 3 until my left side. So it will be 0, negative 1, negative 2, negative 3, negative 4, and so forth. So we punch in x equal to 1 here to be 1 squared plus 4, which is basically 5. 0 in here to be 0 plus 4, which is basically 4. Negative 1 here to be what? 1 plus 4, which is what? 5. Negative 2 in here to be 4 plus 4, which is 8. If I'm not mistaken, yeah. Negative 3 in here to be 9 plus 4, which is what? A 9. Am I correct? 2, 4 squared, then 4 plus 4, which is 8. 3 in here, squared plus 9, this is 9. So you are just replacing the values of x. This box, it is for x squared plus 4. So, but for this one, we use greater than 1 values. For 2x minus 1, we'll use the box greater than 1 values. So if this is my x greater than 1, so 1 greater than 1, that's 2, 3, 4, 5. It's up to you. So what is going to happen? I'm going to have, when x is 1, 2 minus 1 is be 1. When x is 2, 4 minus 1 to be what? 3. When x is 3, 6 minus 1 to be 5. When x is 4, 8 minus 1 to be 7. When x is 5, 10 minus 1 to be what? A 9. So we just plot those values. So this is 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. In those range. 1, 2, 3, 4, 5, 6, 8, 9. So we have, for the left side, we have 1, 5. So we have 1, 5. So now, for piecewise functions, at the boundary x equal to 1, we have to draw some circles for each graph. So for example, these circles will be determined by the inequality. If it's x less than 1, then the circle I'm going to draw at that particular point should be open. So now, at x equal to 1, I have comma 5. 1, comma 5. It is at this point. So it's at this point whereby before you start drawing your anchor and circle, check your inequality. The inequality is just basically this side. It doesn't have an equal to, so it means it's not supposed to be equal to 1. So at this point, I'm opening my bulb, which is an open cycle. You continue 0, 4, 0, 4, it's this point, negative 1, 5, negative 2, 8, negative 3, 9, 7. So this is a parabola moving in that direction and connected to the circle here, which is open. You open your circle, not shaded. So this graph is basically y equals to x squared plus 4. And on the right side, it starts again at 1, 1, isn't it? So 1, 1, you have to draw a circle, but this is equal to. So 1, 1, you open your circle, but since it is equal to, you shade this circle. I continue the corners 2, 3. Okay. 3, 5. 4, 7. 5, 9. So this is a straight line moving in that direction. So this is the y equals to 2x minus 1. So this is how a piecewise function behaves. So what am I going to have? The demarcation is being drawn based on the intervals. So if I had 3 intervals, look at how many demarcations you have. Be able to draw the intervals and be able to sketch for all kinds of graphs. So I've experienced a number of mistakes in piecewise function which you people have been sending in the exercise we've been giving you. So be able to redo and correct 1 or 2. Let's look at another one, B. So let's look at the second one. If you look at what is happening here, how many boundaries in the interval do I have? I have x equals negative 2 and I have x equals to 2. So these are the only 2 values of x in the intervals. There are only 2. So it means that in your Cartesian plane, you will be able to draw your demarcation at those points. We're going to draw, this is 1, this is 2. This is negative 1, this is negative 2. So the first boundary will be at x equals to 2, which is this one, or this one. And the other one, it is at x equals to negative 2, which is this one or this one. So the graph here is being drawn as how? The first part, it is for x less than negative 2. X less than or equal to negative 2, it is this function. So this function will be drawn less left for negative 2. In between negative 2 and 2, it is f of x equals to 3 per cut. Greater than 2, it is the root of x minus 2. Okay? So it means that if I'm creating for this one, a table of contents can be x, y. So less than or equal to negative 2, we can start at negative 2, negative 3, negative 4, negative 5. We are going to the distant part. What are the values of y? It's negative 2 here. I'm going to have negative 2 minus 1, which is negative 3 squared, 9. 1 minus 9 is negative 8. Negative 3 here, negative 3 minus 1, which is negative 4. Negative 4 squared, that's 16. 16 minus 1, that is negative 15. Negative 4 there, 5 squared, 25. 1 minus 25, that's 20, negative 24. X, y, negative 2 inserted in there, negative 8, negative 3 inserted in there, negative 15, negative 4 inserted in there, negative 24, and the count continues. But for this one, f of x equals to 3, whatsoever value of x you insert, the answer is to be equal to 3. That's how a constant function behaves. So this table of content will be for 1 minus x minus 1 squared And then for the table of content of f of x equals to 3, what is happening for every value of x you insert negative 2, negative 1, 0, 1, and 2. The answer will still be 3, 3, 3, 3. That's how a constant value behaves. You can't see a variable x on 3. So whatever value of x you insert here, you still have 3, 3, 3, 3, 3. And then for this one, root of x minus 2, you can do the same table of contents. X, y. When x is what? 2, when x is 3, when x is 4, when x is 5, when x is both greater than values. Basically, when x is 2, obviously it's starting at 0. When x is 3, root 3 minus 1 is root of 1, which is 1. When x is 4, 4 minus 2 is the root of 2, which is 1 point something. Root of 2, when x is 5 there, 5 minus 2, that's root of 3. When x is 6, 6 minus 2, that's 4. And then root of 2, that's 2. In those cases. So what am I going to have? I'm going to have 3, 4, 5, 6, 7, and continuous. This is negative 3, negative 4, negative 5, negative 6, and it counts continuous. Here I can say, okay, this is 2, 4, 6, 8, 12. 2, 4, 6, 8, 10. Count continuous. 2, 4, 6, 8, 10. Negative 2, negative 4, negative 6, negative 8, 10. In those lines. So, negative 2, comma negative 8. You open your bubble here for this phase function. Negative 2, comma negative 8. Negative 2, comma negative 8. So the bubble will be what? Open and shaded, because x is less than or equal to negative 2 for this function. And then negative 3, comma 15, it is coming down. So this is basically a parabola facing downwards like that. That's a curve going downwards. But x, f of x equals to 3, that's basically at 3. A straight line passing through at 3. When you bump your curve, you open your bubble. Open your bubble this side. There will be open bubbles because these are not equal to. Root of x minus 2, starting at 2, 0. You open your bubble here, but it is shaded because it is uncut. So your graph is going to move like that direction. That's the root function. So this is the f of x, or maybe y, equals to the root of x minus 2. This is y equals to 3, and this is y equals to 1 minus x minus 1 squared. So we have all joined all the functions on one Cartesian plane. So we just look at the conditions attached. These are the ones you open. You draw your demarcation, open your cycle for the function which is equal to, close your cycle, shade your circle for the inequality which is equal to for that function. But open the circle for the function which is not equal to that inequality. So we have another one there. First thing, as usual, look at your intervals. Determine your intervals there. What is happening? You have x equal to 1, x equal to negative 2. So it says x equal to 1 and x equal to negative 2. Those are the only values we are seeing for x. So in the Cartesian plane, so we have 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5, and this is 0. So x equal to 1, it is this line passing through at 1 on the x-axis. X equal to negative 2 is this line passing through at negative 2 on the x-axis. Then we start sketching. For 5 plus x, the table of contents can be x, y greater than or equal to 1. 1, 2, 3, 4, continues just like that. So when x is 1, 5 plus 1 to be 6. When x is 2, 5 plus 2 is 7. When x is 3, 5 plus 3 is 8. When x is 4, 5 plus 4 is 9. The table of content for f of x equal to 2. This one is a constant function. Every value of x insert, the value of y becomes 2. So from negative 2 to 1, negative 2, negative 1, 0, and 1. All the value of x insert, you still have a 2. But for the last one, we have f of x to be less than negative 2. So negative 2, negative 3, negative 4, negative 5, and so forth. So what is your y when it is negative? This is negative 2. 1 minus 4, it is negative 3. 1 minus 9, negative 8. 1 minus 16, negative 15. 1 minus 25, negative 24. So what am I going to have? 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, 14. So this is negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, and negative 14. So negative 2. So this one is 1 minus x squared. It is the one for what condition? X less than negative 2, this side. So negative 2 comma negative 3 here. What will be my circle? You open your circle like that because it is not equal to negative 3 comma 8. Negative 3, it is somewhere there. Negative 4 comma 15 is somewhere there. Negative 5 comma, that is down there. So this curve is going to move in that direction. Y equals to 2. This is 2, 4, 6, 8. So it's just a line from passing towards 2. Open your circle here, open your circle here. But this one, it is equal to at negative 2. So the line at negative 2 is shaded, but you open it here. For this one, 1,6, 1,6, you open it here. So it is equal to 1. So you shade 2,7, 3,8, 4,9. So this is straight line moving in that direction. But the circle here is shaded. This is y equals to 5 plus x. This is y equals to 2, and this is y equals to 1 minus x squared. Those are piecewise functions. Try to pass through a number of them, solved you a document, at least you're able to go through. Thank you very much. Blessed day.